Hello. Today I'm going to show you why pi is equal to what it is, which is something like 3.14159226. So something like that, and it goes on for infinity. So it's a very interesting number, and today I'm going to show you how to calculate. Oh yes, and last video I proved that pi does not equal 4 because because there's a popular internet myth that says it does, and I disproved that in the last video if you want to go check it out. Okay, so this is what we are going to be doing today. So to start this proof, we are going to need a right triangle. So let's make our right triangle. Okay, that's not a good right triangle. And now we can use, now let's make this. Oh, sorry. I must have been using the wrong tool. Okay. So, here we have our angle, and that is just pi over 4. Oh yes, and this is a right triangle, so we can have that. And we can have our other angle. Oh yes, sorry. Our other angle is going to also be pi over 4. And this whole video we will just be dealing with radians, no degrees. So if you haven't learned radians yet, I might make a video in the future, or you could just look it up. They're pretty easy to learn. Okay. So now, this side is equal to 1. Let me switch colors. So this side is also equal to 1, because the angles are the same. And this side is equal to the square root of 2. Okay. The reason it's equal to the square root of 2 is because of the Pythagorean theorem, which states that a squared plus b squared equals c squared. Okay. And when we substitute, it becomes 1 squared plus 1 squared equals c squared, or 2 equals c squared, and c is just equal to the square root of 2. And this is, oh yeah, and c is the hypotenuse, and a and b are just the legs. And this only works for right triangles. Okay. So now let's do a bit of trigonometry. So the tangent of an angle. So let's see. So the tangent of angle theta is equal to the opposite side to theta divided by the adjacent side to theta. So let's do it for pi over 4. So we have that let me do it down here. So the tangent of pi over 4 is just equal to the opposite side, 1, divided by the adjacent side, 1. Okay, so that's just going to be equal to 1. So now we want pi over 4. So let's take the inverse tangent of each side. And I'm going to be using the name arctangent for it, and they're kind of just interchangeable names for the same thing. And it can be either written as arctangent, atan, or tangent to the negative 1 power. So I'm just going to be using tangent to the negative 1 power, but if you see others use different ones, then they all mean the same thing. So let's just take the inverse tan of the tangent of pi over 4, And that's just going to be equal to the inverse tangent of 1. I could squeeze an n in there. Okay. So we can cancel these out, and we get that pi over 4 is equal to the inverse tangent of 1. Okay. So how can we use this? Well, it turns out there's an infinite series for an arctangent of x. So let's take the arctangent of x, and remember this only will work in radians. This will not work in degrees, so please do not try it. So there's an infinite series representation for this that is so infinity sigma n equals 1. And don't worry if you have not learned sigma notation, it's pretty easy to learn and you could just look it up. So and we're taking the sum of this series. So yeah, and it starts at n equals 1. So we're gonna do -1 to the n plus 1 power, and that just means that it's an alternating series. So it's gonna be plus minus plus minus plus. So and then times x, the angle, to the 2n minus 1 divided by 2n minus 1. Okay. Now, what we want to do with this is get it for 1. So let's do that down here. So, let me do a different color. So now we have infinity sigma n equals 1 -1 to the n plus 1 power times 1. Because 1 to any power is just 1, divided by 2n minus 1. Okay. So now, what? Now, in terms of pi would be equal to 4 times this, and I just multiplied each side by 4 here. Okay. So if you know about sigma notation, you can know that we can multiply a constant by it. So let's do our series representation for pi. It's going to be pretty important. So I'm going to switch to a different color. So pi is equal to infinity sigma n equals 1 -1 to the n plus 1 power times 4 divided by 2n minus 1. Okay, that's really good. Now we have a series for pi. So that's really good, I think. So the only bad thing is it takes about a few million terms of this series to be able to get just a few digits of pi. But it's a very simple way to get pi, and it's a series representation. So let's just do a few terms. So let's work with the first term. Let me switch colors again. Okay. Okay, that color works. So we start with 1. N plus 1 is just 2, so it's -1 squared, which is just 1 times 4. So it's 4 divided by 2n minus 1, n is just 1, so it's 2 minus 1 over 2, so it's just 4. And now remember it's alternating because of this -1 to the n plus 1 power, so it's going to be minus 4 divided by, now n is different, so it's going to be 3, because 2 times 2 minus 1 is just 3. And as you can see, this one's going to be increasing by 2 every time, the bottom section, so we don't have to recalculate each time. We can just do 4 over 5 minus 4 over 7 plus 4 over 9 minus 4 over 11. And it's going to go on for infinity. And the more terms we do, the closer and closer we get to pi. So, I think that's really important. So, let's square on this. Okay. So I hope you learned something today, and please check out my other videos and subscribe to me. So, thanks for watching. See you next time.